Good morning to one and all present here. I am Jeel Panchal, a third year student. Good morning to one and all present here. I am Jeel Panchal, a third year student from the electronics department. As quoted by Terry Mann, a career is not about earning an income. It is about pursuing the essence of your life. Life is about choosing the right path. We at V-REACH aim to help you through it. It is my pleasure to extend a warm welcome to you all on our first session of V-REACH, an alumni engagement initiative of VESIT organized by the Electronics Department under the guidance of Internal Quality Assurance Cell in association with the institution's Innovation Council. It is a part of sessions that we are going to do with our esteemed alumni where they share their knowledge and experiences with the students. I am profoundly delighted to take an opportunity to introduce our guest of honor and speaker, Mr. Sagar Bokre, sir. On behalf of the Institute, I cordially welcome you, sir.
Thank you.
I now request the head of our department, Mrs. Kavita Tiwari, madam, to give the inaugural address.
Thank you, Jeel. Good morning, students. I welcome you all to the third series of V-REACH Alumni Interaction. Today's topic is related to IoT. The common examples of applications of IoT are smart homes, self-driven cars, retail shops, and smart irrigation. Some of the industrial applications of IoT are in the field of quality control, supply chain management, smart grid. I welcome our guest speaker, Mr. Sagar, to update you all with the current trends and development in the field of IoT. I am thankful to Dr. Abhay Sagar and Mr. Abhishek Chaudhary for arranging this session. Thank you all.
Thank you, ma'am, for sharing your thoughts. Today's speaker doesn't require an introduction as he is a well-recognized personality. Mr. Sagar Bokre, sir, has completed his BE in Electronics Engineering from VESIT in 2008. He did his MTech in Electrical and Electronics from IIT Bombay in 2011. He has also been a consultant at Zlearn as well as a senior system software engineer at NVIDIA and has hands-on experiences in artificial intelligence, deep learning, wireless media streaming, GStreamer, to name a few. Sir is also skilled in photography, device drivers, Python, C++, and Eagle PCB. A thorough professional with a self-driving car nano degree focused in automotive engineering from Udacity. We are fortunate to have you here, sir, for this interaction, and I'm sure we will be benefited by your presence, words of wisdom, and experience. Today's topic of discussion is exploring career opportunities in IoT and Industry 4.0. The audience is allowed to put up queries and doubts in the chat box while the session is on. We will address it at the end of the session. I would now like to call upon the speaker for today's session. Over to you, sir.
Sir, your audio. Right.
Hello, am I audible now?
Yes, sir.
Yeah, really thank you for the introduction, Jeel. I think I have not done that much to be worthy of that much praise, but how much ever it is, I'm really honored. So let me tell you a bit more about my understanding, my knowledge, and my learnings from the journey. So the today's talk, which we have here, is going to be focused around two objectives: the objective from my end and the objective from the student's end. What I need to convey and what probably could be some understandings and learnings for the students. So the objective for me today is to introduce you to an ongoing era, the Industry 4.0 era, and give you ample food for thought, ample pointers for that, so that you could explore them, you could search on them, and if they find relevant and interesting to you, then you could explore a career in those domains. And also to share my experiences and learning as we go along. I would see that the objectives would be complementary for you guys. You could learn from the mistakes and experiences I have. You could also learn and get pointers to the current ongoing era and see if there are relevant pointers, go explore and make career or future in them. Before we go into what entails, let me give you a brief sum up of what have I done in the past. As mentioned by Jill earlier, during my undergraduates or just after my undergraduates, I was working with ZLearn to frame career for ongoing students in the school. This STEM method of introducing curriculum to the students, that is science, technology, engineering, and mathematics. So I had designed robotics curriculum for students there, where they could draw a triangle using a robot. They could also navigate a robot to remote places using remote controls. And all of this was done without writing a single line of code, using block diagrams and pulling together blocks which they could use. After that, I continued with my engineering and post graduations. At that point in time, I was working on wireless sensor networks. I was working with robotics at that instance too. I was a part of Robocon for 3 years, and I was also involved with Telecrema. Going ahead, in masters, I was involved in a defense project where we were trying to estimate the parameters of a radar signal, um, underground vehicle, underwater vehicle, where we try to understand if there are nearby vehicles without even trying to encroach their territory. Um, and I was also involved with DIAT and DRDO, where I was working with navigating through obstacles without running into them using neurofuzzy inference systems or a small miniature form of AI at that point in time. And my stint after that has been in the corporate sector only. I have been associated with NVIDIA since the start of my career. And in NVIDIA, I've got the opportunity to work on AI and ML. I have also got the opportunity to work on embedded systems to the core level. The experience in NVIDIA spans across device development, device driver development. It also spans across developing the co-pilot interface. Co-pilot is like an AI assistant in the car, where we try to gauge the person's mood, rather than that, also the eye gaze and pose and other parameters which we need to understand if the driver is in complete control, if he is drowsy, if he is angry, or so on and so forth. Um, Going ahead, I was involved in another project which was relating awareness in the car. We used to find objects inside the car and make the user aware of the current scenario. For example, if the user left his wallet inside, if any user is approaching the car, do we want to open the door? If the user is wanting to exit the car, do we want to allow them to open the door because there is an oncoming vehicle? You would not want to, run into those vehicles while you open the gate. If a person is approaching the car and wants to open the bonnet or the hood, we need to understand that there's something in his hands and he is occupied and he cannot engage his hands for doing those activities. So probably just a gesture or a command, voice command, which he could issue to open the trunk. And going ahead in the same domain, I was involved in productization of it. Then I migrated and moved ahead to another project where we are now dealing with safety of the users of car. We want to ensure that whoever is driving the car is not running into a situation where the system has failed, but the user does not have control over it. We want to ensure redundancy, we want to ensure security, we want to ensure safety of the users driving the cars. And that's about my experience till date, the summary of it all. And what I feel as relevant from my undergraduation and learnings is following subjects who are of interest. The white dots which are being mentioned in the presentation are my areas of experience. I would not call it as an expertise, but I have explored in these areas and I have had the opportunity to work on them. I was lucky enough to have that. But other relevant areas which I think are also needed going forward in the ever-growing era now are the ones which are not in white color, white dots post-appended. Embedded systems happens to be the most important area, because we cannot develop any system without an understanding of how the even system is comprised. What is the system comprised, and how do we enhance it, or how do we evolve it further so that it is faster, leaner, less power hungry, and so on and so forth. So it involves concepts of embedded systems, how the bus architecture, the microprocessors and controllers in it work. The second most important requirement as of today for Industry 4.0 is AI and ML. I'll get to what Industry 4.0 is if in case there are people who are not aware of the terms there. But for the time being, I am just highlighting the relevance to our curriculum right now. Microcontrollers and microprocessors is another area of interest which people should have some experience. And programming, this topic is needed almost everywhere in engineering nowadays. Digital design and electronic systems, if you have some understanding of concepts involved here, your path through this journey would probably be easier. And analog circuits, I believe this is going to be some sort of a future, because there is a limit to what digital system can do and how fast it can scale. But analog circuits, if they are handy and available for processing data, then they would be much more faster, and they can solve problems much easier compared to what digital systems are doing. That is my opinion. Might not be aligned with what others think. And system design is going to be needed once you have a hold of the above, because you want to build a system which is scalable, you want to build a system which is deployable in real environment, and you want to build a system which is secure as well as safe. You cannot live with a situation where your system probably does not function once in 1,000 times, because those 1 in 1,000 times could be lethal for a person driving a car. So system design is one such aspects you need to focus on going ahead in the career, if in case you want to flourish in the same technical domain. All having said with relevance, I'll probably go to what Industry 4.0 era is. To give you some background, Industry 1.0 was the phase in which we were introduced to machines, machines who could harness the power of wind energy, who could harness the power of water or steam or tidal energy. And we could use those forms of machines to do things which we require attention most of the time. So it's offloading our attention so that we could focus on something important. We had steam engines earlier, and we also had engines we could convert wind energy to a mechanical form of energy. Then came Industry 2.0 era, where we had access to electricity, we had access to infrastructure. By that I mean roads and bridges and so on and so forth. We were capable of harnessing this power to build strong metals and also machineries which could ease more things for us. Then came the Industry 3.0 era, where the computers were introduced and there was a World Wide Web which was available for access. The information which trickled down to human beings or us in general was at a much faster pace as it was compared to in Industry 1.0 and 2.0. So if you go along in the history, you would see that Industry 1.0 took a lot of time to come up. Then Industry 2.0, a little lesser time. Industry 3.0, an exponentially lesser time. And Industry 4.0, it is at lightning speed right now. So as you go and progress ahead in this hierarchy, you would understand that progression of development of an era is short spanned, and you need to evolve very fast to keep up with the pace of that era. That's the reason why I am trying to align or highlight the subjects which are of interest, so that you could focus your attention on those relevant subjects. So as of today in Industry 4.0 era, which is majorly connected devices, devices which can talk to each other, which can understand the environment, which can interact with each other, is currently the state of the art. I might be wrong in terms of knowledge, but that's where I understand the current state is. We have lots of devices available, connected to the internet, connected to the cloud, which are capable of exchanging enormous amount of information with each other, and they can take decisions on our behalf. Decisions which we think are mundane, which we do not need to focus on in our daily activities. And as we go progress ahead in the evolution, we would see that more and more things which are relevant for us now, consuming a lot of our time, would be offloaded to machines. So for an example, you would drive to another place, I mean, from one place to another using vehicles, but that need not have human attention all the time. So we are developing autonomous machines which can do that for us. We want to keep our schedule tight and organized. We do not need to focus on that. We could have VI assistants and co-pilots doing that for us. We want to have systems which can probably assemble a machine, and we have been doing that for a long time now. But we need not focus on that again. We could have smart devices which can coordinate the inventory, which can coexist and inform each other that this is the state of information right now. Do you want to evaluate and update, or do you want to stock up again, so that you could have enough resources available for continuing the functioning? So that's how the assembly line is currently being developed. It's being deployed in, say, modern factories like Tesla factory, the Gigafactory which has come up. There are machines which are automated there. There are less avenues for people to intervene and take up that activities, but still human intervention is required. So they communicate if the inventory is available. They also communicate if a particular activity is to be taken up by some other machine or not. So systems are coexisting with each other, communicating information. And in our real life, we see a lot of connected smart devices. We have these smart watches. We also have Google Alexa, Google Home, Amazon Alexa, Google Home, and so on and so forth. So these AI virtual assistants are ubiquitous. I mean, you could find it anywhere and everywhere these days. We are somewhat dependent on these devices, but going ahead, we would need these devices around so that we can think of more complex problems to be solved. There is another topic which Industry 4.0 era is also concentrating on, which is AR and VR workspaces. As of now, we are using, say, Google Meet to interact with each other, but this is only limited to exchange of vision data and exchange of audio data. But what if you want to work on a project collaborating with other of your students? So say you want to develop a model, a virtual model uh, of a car, and for that you would need to interact with other students, understand from them what the car model is. What if I told you it would be more flexible and more fast if in case you all hooked up into a virtual environment, all of you standing together, and you try to exchange information via whichever means you like. You create a model collaborating with each other. One person develops the wheel, the other person develops the bonnet, and the other third person probably develops the interior. So you can collaboratively work in a non-existing environment. That's a virtual environment. We call it VR for virtual reality and AR for augmented reality. So in AR, you would have objects projected in the real environment, but in VR, the environment itself is virtual. You work in virtual environment and you create virtual objects, which can then be materialized into physical objects realization. The other topic, which is currently gaining more traction, is high frequency trading. You all might be aware of cryptocurrencies and stock markets, right? So gone are the days when people used to sit in front of the terminal and trade stocks. Majority of the bulk of orders which are currently happening in the stock exchanges are happening via bots. And these bots are high volume, high frequency. I mean, they punch in orders in a matter of microseconds and milliseconds. The problem statement which these guys are trying to focus on and solve is the vicinity, or the nearness to the server. The more they are closer to the server, that will be the microsecond worth of or millisecond worth of delay which they are trying to avoid, so that they can punch in order more faster than the others can potentially do. And they are taking decisions in the blink of an eye. If they see that there is an ongoing high volume order, they change their trajectory, and there are traps which are introduced for normal functioning investors. So yeah, there's a different world altogether in high frequency trading, which is ongoing now. Other field which we have is the last mile delivery. You would have seen in the US. This currently is not happening in India, but if you see that there is a delivery happening to a different state, um, the last mile delivery is usually done by human beings. There's a human intervention involved, that person would deliver it to the doorstep from Amazon or some other provider. But they are also trying to offload that using quadcopters or using Segway type vehicles. These vehicles navigate through crowd. These vehicles are small in form factor, but they eventually end up even the mundane job for the delivery boys, so that where there is a dearth of resources, they can deploy this last mile delivery solutions. There are automated warehouse for very big warehouses these days, for like Amazon, which have to deliver tens and thousands of orders in a single day for a region. Um, so these warehouses have to be automated, because we cannot keep a track of how many resources would be available in what time, and how frequently to stock them up, and how frequently do they want to be updated in terms of price. So all of these activities are being offloaded to the computers and machines now. The other thing which was slightly covered in earlier topic was the health monitoring systems. Again, the ubiquitous systems have we have armbands, we have devices connected to our mattress. We can tell them. The devices can tell us if we are having a good quality sleep or not. And going ahead, they would also define how good our routine should be, so that we have good, healthy lifestyle going ahead. So this is what Industry 4.0 era is as of today, and my experience is relevant in the stream of autonomous machines. I have had the experience of developing an autonomous vehicle to a small scale, where we were limited in the area we want to function on, and we need to navigate through the area with only image data. Um, so my learning from that domain is, it is not an easy problem to tackle. It's a very difficult problem, and the scope of how do I tell it? The scope of influence it has on human life is humongous. For an example, there was a Uber incident 3 to 4 years ago, wherein one driver was not paying attention to the driving zone, and while texting, they ran into another pedestrian who was driving a cycle. So that was one problem. Probably it was because the technology was not involved enough, but they still wanted to deploy it in real scenario. Um, so these problems would happen, and it is really challenging to solve them. We are lucky that we are in this era, and we would be getting to work on really complicated problems, really aligned with autonomous machines, if in case that is going to be one of the futures. Then I have had the experience of working with Copilot, where we designed a system to estimate the gaze of the user, where he is trying to see in the car cockpit. If he is looking at the rear view mirror, side view mirror, or the infotainment system, or the actual road region. If in case the user is not looking at the road region for a long amount of time, we alert the user and attract his attention back to the road region. We also tried to check if there was some sort of drowsiness in the driver's eye gaze. If in case the eyes were closing and opening at a particular interval, and those were intervals much more than the blink of an eye, we used to keep a track and inform the driver through haptic feedback that your gaze is not correct, and you would want to improve your attention on the road. Uh, I was also involved in coexisting systems, where we tried to develop a system which could learn from other systems. For an example, as of today, you would be aware that because of COVID, the masks were of use, in all the areas. But for all the systems which were currently designed for face recognition, they would fail to some extent. I wouldn't say they would fail like 100%, but 30 to 40% plus of accuracy was compromised. So how do we tackle with this problem? So we developed a system which was now, addition of another system on top of this. Say the face recognition evaluated the identity of a person, but we do not yet know if he is the person to be 100% sure. We added audio data also to be captured, and we asked the user to speak in front of the camera. If the audio data in the microphone captured aligns with the image of that person, we train the image recognition or the face recognition system to improve the accuracy based on the current set of inputs. We would say that the audio data is 100% sure this is person A. So you evolve yourself and train further to say that going ahead, I am going to detect this person as A if I see similar picture. And this is the theory of relevance. I mean, you try to work on the most relevant data in the immediate future or the immediate past, so that the system's accuracy stays intact. Uh, this would also be aligned when there are no non-code system, not code, non-code scenarios. Say a system detects a person without a mustache and a beard, but after a few days he tries to log in with a beard and a mustache. He may or may not recognize by the system. So, if the system is not able to recognize, we will request for more audio data. The audio data would try to evaluate the person, and the facial data would now be more accurate. The other way is also true. The face of the person is intact or similar to what it was trained with, but the audio has changed a bit because of cough and cold or any other background situation noise. So we train the audio system saying that the video system is now accurate and sure about this. You want to update your database with the recent most data. And these both system assist each other, coexisting systems, and they evolve with time. And you do not need to intervene and change the database every now and then so that they stay relevant. The other thing which I was also working on was connected smart devices. I mean, this was a hobby project, but I tried to develop a system which would unlock the door if the person is seen in front of the iFinder. So you just stand in front of your door, and if in case the system detects your face, it will try to open the door. Yeah, I didn't complete it, to be frank with you, but I had a prototype available, so I have some relevant experience in this field. Again, the learnings from these fields is that you have to struggle a lot to stay relevant for the industry. If you see that my expertise was in computer and databases, as in Industry 3.0 era, I would be completely, or if not completely, partially irrelevant for Industry 4.0, because those are not the requirements as the industry progresses. The requirements also change with time, and if you do not keep up with the pace, it's pretty how do I put it? It's pretty fast, and it's not that obvious, but we turn out to be relevant in some amount of time. So yeah, keeping up with pace is something which we need to always strive for. Now, ball in your court is something which you can currently look up, something which you can currently do. Immediate goals, I would say, to stay up to date or probably contribute to this era. One of the opportunities is via academia. You could focus your attention on post graduation, try to write a thesis, try to go to a PhD, trying to understand and learn the current nuances. You could work on a research project by collaborating with people from other universities and other institutes. And in engineering, you could work on the design developments and support of systems which you are interested in. Probably develop a hobby project which you think would be of any use to anybody. For an instance, like in COVID times, you had masks enabled, right? You would design a system which would detect people who are coming together in restricted area. Like if you do not want more than two people to be interacting with each other without wearing a mask, you could design a system which could try to detect that. That's just an example, but there are many myriad of examples which you could think and come up with and work on. Nobody's stopping you. In the private sector, you could engage yourself with a startup, you could engage yourself with any establishment in the form of internship, or you could also work on freelance projects. You could also take up projects on your own while collaborating with other students. So these are avenues which are open to you as of today in the private sector. The government sector is a good thing in case you want to give it back to the society, but I would be very much involved in this because that's my interest, but it's a personal subjective opinion. So you could take up projects with the which the government needs. There are many sites which are floating projects which are to be addressed, or problems to be addressed. I see problems from defense sector where they are looking for solutions to mining. um, there are landmines in some areas, and government is looking for solutions as to how AI can be enabled to tag those regions. And then once those are tagged, flag it to a central database location that these are the regions where we suspect mines to be available, so that they can send away indispensable robots, and they can send away indispensable objects there, so that the mines can be either diffused or they can be triggered. So there are other research aspects which you could work on. There are DIAT, DRDO, and other institutes which are looking for research solutions. You could collaborate and work with them, understand better if there are fields which you can contribute in. And there are other engineering solutions not relevant for government directly, but yeah, if you think your solution is going to help the government or the nation in any way, you could develop the project and then float it via your seniors to authorities which they can deploy. So this is what you can do right now. I will be going to topics which you can aim for going ahead in the future. The sectors are not coarsely defined. I mean, the sectors are not demarked correctly. But these are the focus areas which I could think upon, and I could come up with. So product and service is one such area. People would need devices which are available in day-to-day life. They would be edge computing devices, or cloud computing devices, or backend devices. The examples for these would be, you might be aware of Kinect and Netflix. So these companies are looking for solutions where they could identify people and their faces, so that there is no account theft or sharing of password, or for that matter, relevance of data which is being given out. So they might want a particular set of movies to be rendered and streamed if in case they see one person, depending on his age group and gender. They might want to show another curated list for another person in front of the TV. So they are looking for edge computing. By edge computing, it means the devices which are available at the users and for disposal. Cameras is one classic example. The cloud computing is one in which the inferences and the computation happens at a remote end in a heavy system. By heavy, I mean computationally intense and computationally more capable. So there are services and products required to develop cloud computing devices. There are also requirements for edge computing devices. I have put it in the evolved trajectory because that is something which you cannot do right now. But if in case you align your projects and interests and work in that direction, you could eventually get to these sectors. The backend devices are any other devices which are trying to focus on evaluating the system's health, also evaluating if there is a theft, or say a cyber security concern, or a transaction concern, or any other device which do not live in both these worlds, like the edge and the cloud computing, because they have to be somewhat agile, and they have to be easily accessible to train and update. Um, yeah, these are the major product and services sectors which I could come up with. And there is another universe in all itself, robotics and industry 4.0. As I mentioned earlier, there is a warehouse automation, there is compute infotainment and actuation. So this is relevant for car and last mile delivery. You want to have solutions which can compute fast. There is going to be an increasing demand for amount of data to be processed. We are working with one camera for the time being, but it would not be far-fetched if I think that needing even 20 cameras in front of the car would be enough, because you want to check the entire scenario. If there's a vehicle coming from the left and right, if there are far away vehicles, if there are nearby vehicles, if there are school regions nearby, and so on and so forth. So amount of data which you would need to compute is not going to go down. So you would need even more heavier and bulkier systems, to bulkier in terms of processing power, not in terms of size. So you would have a demand in the industry going forward in these domains. It would not fade away that easily. Infotainment is another sector because you would want Netflix to come up with relevant suggestions. You would want people to be given information which they like more and more often, like YouTube suggestions and the way Instagram also works. So these systems are staying relevant while trying to give more information and making the user more and more addicted to the system. So um, clickbaits and other systems, they would never fade away. As time progresses, they would need more and more contributions in this field. Actuation again was relevant to last mile delivery. You would need more and more robust devices available for actuation. Some of your projects had the hand which was remote controlled. There are other systems. You would want to have robotics, humanoids, and whatnot. The boundary is not yet defined, but it's evolving at a very fast pace. Then there is AI and ML in the backend required so that you at least try to estimate if there is a car, if there is a person, if there's an object, that there's something which you need to avoid and also evolve with time. So at our point in time, 3 to 4 years ago, supervised learning and solutions was the only way. But now there are unsupervised systems wherein you just define a problem statement and the system would try to gather information. It will try to train itself, it will try to evolve, and it will try to attain accuracy at one sample instance. So there are systems which are being developed which would be shown data for only one instance, and they will try to evolve and learn and develop on their own so that they attain as accurate results as possible. So for an example, I will show the robot to pick up an object only once, and I will give the system a robot and I will give the system a black box which is capable of learning on its own. The black box is supposed to train itself to pick up the object using that only one sample. That's the level of AI which people are trying to get to. It is not completely accomplished yet, but the direction is in aligned to that front. Again, a perception planning control is for autonomous vehicles. This again, this industry is not going to fade away in the immediate future. We would need more and more accurate sensors to perceive the environment around 3D, 4D, maybe more resolution, and so on and so forth in terms of perception. You would need robust systems for planning the path of the robot, and you would need robust systems for controlling the robots also. Um, this is one such couple of such sectors here. The other sectors, again, deep within the systems are the embedded systems design and edge device engineering. Um, AV and ADAS. AV is for autonomous vehicles, and ADAS is advanced driver assistance systems. These are the embedded systems which do not come to the surface, but they are doing very heavy powerlifting for the end systems. And if we do not design those embedded systems correctly, there is no potential for AI or ML to run there. So you need fast processors, you need fast memory interfaces, you need fast end devices. And that is possible only through embedded systems design. You would have interacted with gaming consoles, and nowadays the streams are, streams are being streamed throughout. The gamers want to watch other games being played, and you also want to see or experience the game as much realistically as possible. So you need to have a backend device which can handle that much of massive data and give you the required output. Again, another lower level component which you need for that is platform design, be it schematic, layout, power, interconnect, uh, and high frequency, high compute efficiency, and more devices which are being interconnected. So you need to have a robust platform which can support all of these capabilities, and embedded systems design is the way I think is going to help. Then you this is again the future of your career, where you want to architect the system in such a way that you allow backward and forward compatibility. You would be able to have more and more devices connected which can solve even complex problems, while ensuring that the user need not switch away from the system again and again. You cannot have your mobile phone thrown away every 1 or 2 years if in case the technology has evolved as does not support backward compatibility. So going ahead, I believe there would be modular mobile phones wherein you would be able to decide which camera to take from which producer or manufacturer, which memory to take from which consumer, and which processor to take from which provider. So you will be able to put together a mobile phone in future, and that is possible if you have an architecture which is robust enough to support all of them together in a standardized format. So I think this is going to be one of the futures. Not sure if it would pan out that way. Then the edge device engineering, the way I see it now is Google Home is thing of the past. There are more devices coming from Google where they are able to track you while you're in a call, while you're talking to somebody else. They would be able to give you suggestions if in case you are trying to cook something. They would also be able to give you feedback if your posture while being at home was correct or not. Though this is intrusive and I mean on an experimental basis, but yeah, that is the level at which people are trying to solve problems or involve users in their system. Then yeah, these are other things are just examples of what edge device engineering is. You would need to develop a system which is capable of interacting with the user and as seamlessly as possible. I do not want to walk to the hall and talk to the Google Assistant. I would want to stay where I am and talk to the same device. So again, evolution is happening on this front too. Um, for systems engineering, again, I'm going lower into the system. What we spoke about earlier was the overview. These are the nuts and bolts. What we need in the current era. There are firmwares and middlewares being developed. These firmwares and middlewares have to be faster than ever, capable of handling massive data and leaner than ever before. They need to load in say microseconds or milliseconds, and they need to start executing as soon as they're booted. So you need a robust firmware and middleware which can allow the operating system to be loaded and executing in a matter of no time. You need robust drivers, you need features which are required from the user end, and you need performances which can match the speed of light. Um, there's a growing concern now for safety and security because the more devices which you have on the network and cloud, the higher chances there are of breach and somebody else gaining access to your personal information. So you want to have a secure system. At the same time, you want to have a system which does not fail often or does not fail at all. So there are design considerations around redundancy. You would want to have a microcontroller available in the car, maybe two of them, so that if one of the system gives you a false output or incorrect output, the other system needs to be there to protect you and say that this is a false output. This is the way it is expected to be, and let me take control of the system for you while you recover back. So this is where systems engineering is heading right now, and that's the level of complexity that people are trying to address. In optimization and feature development, this is the lowest level I could think of. You need to dive into the code. You have written a machine learning algorithm, but the kernels which are there, but kernels are the individual blocks which are run in a neural network. If that is not efficient enough, it is not able to process data in a microsecond or a millisecond, then there is going to be a cascading effect on the entire output. Say if you have 500 layers, 1 millisecond optimization would save 500 milliseconds in the total execution time. So that's the granular level of detail, finer level of detail. You need to optimize the kernel and the scheduler to see if you could run more processes in parallel. You could have more threads instantiated to address parallel problems. And you would also need tools to ensure that these things are being taken care of. You need to understand if there was even an optimization. You would run 4 threads in parallel, but you don't know how much each one of them took. So you would need tools to understand for multi-process co-processor based systems, and these tools need to be handy to estimate and give you a feedback of your direction. Are you progressing in the right direction or are you regressing? So that is the lowest level of requirement as of today. Um, Okay, so what I think should be helpful, or what I think should be useful for you guys is what I call snowball pearls. These are pearls which keep on rolling and accumulating in size and structure, and until they reach the bottom of the mountain, they're humongous, and um, the momentum and trajectory is something which cannot be easily neglected. So if you are adaptable, that's going to help you a big deal. By that I mean, say you are in an industry and you want to focus on developing your technical knowledge. It would be good to align with the industry and also align with what you want to work on. So classical example is, if you work on your interest and not contribute to the industry would not want to keep you. And if you contribute to the industry and not work on your interest, you would eventually run out of steam and think about quitting and taking up another opportunity. So either adapt to the situation and evolve yourself while contributing both to yourself and to the industry. That is something which I would like to stress on, one major quality. The other thing is your projects and hobby projects. Choose your engineering project or whichever project you're working on wisely, thinking that this would have a snowballing effect in the future. Because if I talk to you from an industry perspective, all I know about you is what have you worked on and how good are you at what you did. And I can evaluate that based only on the projects and activities you have done till now. If I see that you have done a project in say robotics, I would like to understand what have you done, what is innovative in it, how did you contribute towards the project, and how did you come up with the solution, if there was even a need for the solution to exist. The second, third thing is hobby projects, because to for the industry to understand you, hobby projects is one of the second or third major criteria I would know, because I that would help me understand if you're interested in this field or not. Do you take up activities on your own to build up what you are aiming for? Do you take up projects which interest you in solving problems for somebody else or for yourself? And do you do it at your own enthusiasm and drive? That's something which interests everybody. So in industry, hobby projects is also one of the important contributions. The fourth I would rate is internships, just below hobby projects. There would be a debate as to if I want to keep it above hobby projects, but internships are relevant if in case internships would not come knocking your doors. You will have to approach people, you'll have to approach universities, institutes, and other people to offer you some work in the relevant area of expertise. Um, it's not easy to land an internship, I agree, but that is one of the methods which also gives you the industry experience so that you could evaluate if you are built or cut out for this industry, or if you want to maybe explore something else. What industry needs to understand that from your interactions, right? So one of the interactions I am interested in is probably internships. I did not have the opportunity to go through internships, but I probably could have benefited if I had an internship under my belt. Publications, another avenue. I would rate it above internships in some aspects, but I would not say everybody has the opportunity to make publications or create a mark in the research space. So if you have that under your belt, it would again add a lot to your future. So not only does it give you exposure to the research industry and the way it is structured, but it also broadens your horizon and thinking as to how you could potentially solve complex problems and stay relevant. So yeah, these are the snowball pearls I think which would benefit if you have these qualities, then probably it would not be difficult to sustain or evolve and stay relevant in the industry, even flourish, if I would say. My learnings from the past, to sum up, is fail fast. I land on an opportunity, adapt, evaluate, and repeat. If in case you are cut out for this, find an opportunity which is even complex and better than what you're working on. Adapt, again, contribute towards it, evaluate, and repeat this until you feel that. I do not think there should be a phase where you feel content, you achieved enough, and that's all you want to do. That's probably the phase you want to retire. And career is a lifelong journey. I wouldn't call it one-time thing. To sum up my learnings from the past, I haven't seen one of my colleagues who is good at trying but not done anything. But I have seen few colleagues or more colleagues which do not try at all and have not gotten to anything. So you need to strive, you need to evolve, you need to try again and again and again till you get to the point which you are at least comfortable with. Um, Third major point is invest in yourself. You have ample time right now. You do not have family responsibilities. You do not have other responsibilities. If in case you do, that will take up some amount of time. But invest this time in learning something which you want to do in the future. Invest this time in learning um, what you think interests you. It doesn't matter if it is relevant, but if it keeps you happy, that's something you should engage yourself with and evolve there. That's my experience. I would like to communicate that. If you are doing something, do it with complete involvement. There has to be no half-hearted attempts. If you want to do something in IoT, do it with your complete involvement. If you want to do something in management, get involved with management with all of your heart. But don't be under the umbrella that you would take up management probably later and maybe engineering now. Focus on that and do it. Yeah, if it is to do with at least paving a path for yourself, do it, complete it. While you're completing, have complete involvement in the process. Then after that, once you're accomplished, go to a second goal. If you want to go to management, go to management only after you are done completing engineering with all of your involvement. And the last one, that is, this is a recent addition to my list. Maintain a list of failures and learnings. It doesn't matter. I mean, nowadays the trend is that more failures you have under your belt, more people are going to be attracted towards your achievements and failures both. And it's not easy to accomplish in this world, so the failures would be huge. But the failures come with a list of learnings and a set of learnings. If you fail often, fail fast, do that as long as you run out of steam and you land up somewhere you are of relevance and you think aligned. But do that fast, do that often, and keep on doing that until you get there. Yeah, that's all from my end. I think the learnings and experiences were of relevance for you, and I shared my learnings because even I'm learning going ahead, but the industry demands these experiences. And if you stay relevant, you have more opportunities. If you do not stay relevant, the opportunities seem to vanish slowly, though. Yeah, that's all from my end. And there are other slides in the deck, and you could probably get that as a backup. But yeah, I'll be open for questions and suggestions here.
That was a very effective presentation, sir. Your talk was pitched perfectly for the kind of audience that we have, and you have shared a lot of project ideas which are actually the need of the hour. Thank you, sir, for providing a unique perspective towards this topic. I am sure these insights will help us make right choices in the near future. We have some questions by the audience.
Yeah.
Firstly, as an electronics engineer who is going to graduate in a couple of years, what kind of role do we play in the industry 4.0, or will it be dominated by software engineers or the new emerging technologies?
Electronics engineering, right? I
Yes,
would
sir.
say electronics engineering is the backbone of Industry 4.0. I wouldn't call it the optional element. If you do not have electronics engineering, Industry 4.0 simply cannot exist. You need to have embedded solutions. You need to have processors and controllers which are fast enough to process the incoming information. Software stack can potentially give you the avenue to explore that hardware, but if the hardware is not capable enough, it is not strong enough, it is not bulky enough, the software can only do things to an extent, and you would only be living with workarounds rather than the actual clean solutions. You would probably process data slower. You would probably run into situations where you want to support only 4 users in the system rather than capability of thousands of users. So you would eventually run out of steam, run out of options if in case you stick to software. You have to have a robust, bulky, strong hardware which can service your software. Uh, does that answer the question?
Absolutely, sir. Also, there's this question in the chat box. Which company has better work-life balance, AMD or NVIDIA?
I cannot comment about AMD. I have not worked with AMD before. Work-life balance is good with NVIDIA, as far as I can say, because I have got the flexibility to work on my projects of interest. The co-pilot project, which I mentioned earlier, and the project on awareness of the surroundings, those were hobby projects which I pitched in NVIDIA, and I got to work on them. That amount of flexibility, I'm not sure if I would get anywhere else. So I was given a few group of interested people I could work with, and that group of people was working solely on the idea which we thought was interesting, may or may not be utilized somewhere else, but we had that flexibility. If I say the amount of work which we have to do, if you do substantial amount of work which is relevant for the industry, say 70 to 80% of your bandwidth, you have 30 to 20% of your bandwidth available for yourself to do something which probably interests you for the industry or is not aligned with the industry. You could take vacations, you could do anything else you want, or you could work on hobby projects which you think would be interesting for you. Yeah, so I would rate, the work-life balance in NVIDIA to be a 9 point something. That's going off anywhere. So yeah, to answer the question, it is good in NVIDIA. I cannot comment about AMD because I haven't had experience to work with them.
Sure, sir. Also, how has the corporate space changed since you started?
So it has changed enormously. The time I was with NVIDIA, joining NVIDIA back in 2011, at that point in time, I was working with microcontrollers and microprocessors, trying to understand how assembly code works, which register to put where, and how to have OR operations and operations, bit operations, so on and so forth. Then it evolved to driver optimization, where we had hardware assistant hardware. I would call it hardware accelerators. I got to work on that, but then the industry evolved again. We were expected to work on AI and ML, maybe contribute towards research in that domain. And now I'm working on safety and security. Again, I wouldn't have thought of this field when I graduated, but the industry is changing at a much faster rate. As I mentioned earlier, the um deeper the penetration of information is, the exponential would be the rate of growth for an industry. And now that you have information available, accessible everywhere, and any point in time, you would expect the industry to grow at an even faster pace.
Okay, sir. From everything that you've observed, what problems can you cite regarding working in this career?
Problems working with the career. Yeah, it all depends on your mindset, I would say. What are your priorities and what is it that you want to accomplish? It's not a general statement, but I would have say I want more money while working in this career, and I would not get as much money as I would have made if I had been a financial counselor or a person associated with the financial industry. Again, that's a subjective opinion. I would have had more luxury, more opportunities to explore the world if I had been in another industry. But I could not do that because I am working in an industry which is product based. I need not travel to other places. I did not travel to other countries to solve problems for people, which is this case with, I mean, business analyzers and solvers. I haven't had that opportunity, but I did not see that as a shortcoming. I see that as my choice. What is it that I am more interested in, and accordingly take decisions going ahead. So, yeah.
Uh, okay, so lastly but not the least, what advice would you give to the viewers, and also what did your day look like when you were at our stage, and how did you draw that roadmap to what you have reached right now? So were you like always that student who knew what had to be done, or did you like realize it as you took one step each?
No, I did not know what I had to do. To be frank with you, I did not appear the gate examination completely prepared. Um, and the first question which you had is, what is the advice I would like to give? Paddle as harder as you can at this stage in life, because you are the most carefree now, you are the most adventurous now, and you have the adrenaline rush now. Try as much as things as you are interested in. Do it as fast as you can. If you are interested in embedded systems, do it. If you're interested in AI and ML, do it. If you're interested in creating algorithms and bots and trading, do it. Because there's less amount of responsibilities now, and if you fail, you have nothing to lose. um, so that is one advice I would like to give. And the other advice is, do it fast. um, the third thing which you probably asked about was, did I know about these things when I was in engineering? Heck no. I did not have an idea that I would be doing my master's. I did not have an idea that I would be doing this sort of work in my engineering after my post graduation. But yes, I just knew that I am interested in embedded systems and working on it. Maybe hobby projects is the right term rather than embedded systems. If it is making life simple for me, I was interested in doing it. I remember during my engineering days, I used to be involved in my friends' projects, working on their stuff. I was kicked out of the PCB lab few times because we used to occupy those premises and not allow the staff to go home. I used to be associated with the research and development department to work on some of my hobby projects. I mean, this is coming out now, but I uh, I was working on certain projects which I was interested in that point in time. But I just wanted to build stuff. That was my interest. I did not know at that point in time that I would be working in embedded systems or machine learning or AI, for that matter. But I just was interested in few things and I wanted to do them. So what is the routine now? Um, I still like doing personal projects and hobby projects. I continue doing that with my brother now. I can't reveal that project, but yeah, that is something which I cherish doing even now with my family now that I'm back home. Um, Throughout the days, is because this is work from home, the day starts just normally by doing nothing for the first 3 hours of the day, and then I log in and work. In the middle of the day, if I feel like not working, I take a break for a couple of hours, and then I get back to the routine. This happens till 6 o'clock, and after that, I again start working on my hobby project. Then chill out, starting 8 o'clock till the time I sleep or I don't sleep. And this routine continues. So
So one more thing, there's this query in the chat box. Can a master student work on internship during curriculum?
yes. And there was one more point. I mean, just remind me if I forget about masters. To answer the question, yes, there is immense scope for internship while you're doing the masters. It is similar to the curriculum which you have during engineering. It's just that it is more focused and it is towards a thesis or a final project. But the amount of gaps that you have during engineering are relevant for masters as well. So you would have a gap of around a month or two, um, where the courses would have concluded, but the final project would not have started. This happens maybe 3 to 4 times throughout the entire master's duration. You would have a sprint of 1 or 2 months in the middle where you could approach other universities and institutes and take up work with them. But yeah, there's ample amount of time available. So yeah, coming
Absolutely.
back to the other point, which is the masters, I have a different opinion compared to others in terms of going ahead for masters. You have two options. One is going with masters in India or going with masters abroad. People tend to choose abroad option, but I don't think there is any much difference between going abroad for your masters and doing it in India. At least from my experience, I would say that if you do good in India, you would end up saving and earning while you do your masters, which is not the case when you do masters abroad. You would have to shell out money, and you would have to forcibly work. If you're lucky enough to get a job in your relevant stream, it is good. If it is not, then you have to work for 2 to 3 years just to pay off the loan which you have taken for your masters, and then proceed ahead with your interests. So that's one drawback, I think. But the advantage to that is the industry which is evolving outside is evolving at a much faster pace than in India. So there is a pushback from India government and other things, but yeah, you would get a faster development, but some baggage along with it.
Thank you, sir. I guess we've covered all the questions mostly.
Mhm.
I see you're an articulate speaker and very passionate about your subject. You've explained us in the most simplest way possible. Um, we would we would request everyone to please fill the attendance and feedback form that has been sent in the chat box. Okay. Uh, so I would like to express my gratitude to all esteemed delegates, professors, and students of this session for their presence and contribution to make this event successful. I extend our gratitude to our honorable alumni, Mr. Sagar Bokhre sir, for giving us his valuable time and showing such wonderful insights about Industry 4.0. We thank you, sir, for inspiring and encouraging us with your words today. Thank you, everyone, for your active participation.
Thank you all. Thanks, Jean, for this. And yeah, I'm really honored by this. Thanks.
My pleasure, sir.